Friends, let us continue our lesson. How many words can be formed by using all letters of the word BIHAR? Right, BIHAR, there are 5 letters. Right, letters of the word. So he is saying how many words can be formed. Word means it's always a permutation because the order of the letters is important. It's not about combination. Different words will have different order of letters, right? So whenever we say words, it means it's all about permutation. Bihar has got 5 letters, right? And all 5 are definite. Now 5 letters, among 5 letters, we have to pick 5 letters. So what is the formula? 5p5, right? That means 5 factorial by 5 minus 5 factorial, right? NPR is equal to, we already discussed, NPR is equal to n factorial by n minus r factorial, right? This is what we had discussed. So 5 minus 5 factorial is 0 factorial. What is 0 factorial? Right. Earlier we had discussed about 1 factorial. We had also discussed that factorial is something where you multiply until you get 1. You multiply with all the numbers below that number to get 1. But 0 is already below 1. And you cannot multiply 0 into 1. Right. Then also it will become 0. But if you assume that 0 factorial is 0, then this combination will become unlimited. Right. How many combinations or how many words? This permutation will actually become unlimited, which is not so. For this, our mathematicians have defined 0 factorial to be equal to 1. Okay, you should remember this. The definition, by definition, 0 factorial is always 1. Right? You should not worry about this. Then 5 factorial by 1, this becomes. So what is that? 5 factorial is equal to 5 into 4 into 3 into 2 into 1, which is equal to 120. Right. So how many words can be formed by using all letters of Bihar? Because all 5 letters are different. It is 5 factorial. 5p5. You have 5 letters and you have to pick 5 letters. You have to form permutations of these 5 letters. If not just Bihar, if you have any 5 different letters, how many permutations will be formed? It is 5p5 only. Right. To understand it some other way. Right. We have 5 slots. 1, 2, 3, 4, 5. First slot we have to fill with some letter. Let's say we have 5 letters only. First slot, how many ways we can fill? We can use any of the 5 letters, right? We have 5 options. 1, 2, 3, 4, 5. Right. First slot we can fill with 5 options. So it is 5. Second slot you have only 4 options. Because one slot, one letter we have already taken here. Right, we have only 4 options. Third letter, we have 3 options only. Fourth letter, we have 2 options only. Fifth letter, there is no option. Whatever that is left, you have to fill with that. Right. So, what are the total number of permutations that is possible now? This here we have 5 options, here 4 options, here 3 options, here 2 options, here 1 option. So, what is the total? This into this into this into this into this, which is the same thing. 5 into 4 into 3 into 2 into 1 is equal to 120. Right. If you have 5 slots and if you have 5 candidates to put into the slots, then what is the number of ways that you can put candidates? It is actually first slot you have 5 candidates, second slot you have 4, third slot 3, fourth slot 2, fifth slot 1. So total 120 ways. Right. So this is the same problem. Whether it is letter or people or slots, whatever. Here also it is the same thing. 5 letter word. There are 5 options, 5 slots for each letter. Right, first slot you can pick with 5 people, five letters. You can choose with any of the 5. Second slot you have only 4, etc., etc. Right. Now, if you have 5 letters and 5 slots, then it is 5 into 4 into 3 into 2 into 1. What about if you have 10 letters, but you have to pick 5 letters? 5 letter word when you have 10 letters in total. Right. What does that mean? As per formula, it is 10p5. 10 factorial by 10 minus 5 factorial, which is 5 factorial, which is 10 into 9 into 8 into 7 into 6, as per the formula. Right. Let's try to visualize that also. If there are 10 there are 10 letters, first letter, you can fill in 10 options. You have 10 options to fill. Right. Second letter, you have 9 options. Third letter, you have 8 options. Fourth letter, you have 7 options. Fifth letter, you have 6 options. So what does that mean? This is also same thing. 10 into 9 into 8 into 7 into 6. Right. 10p5 is also the same thing. Whether you do it this way or this way, you will get the same result. But it is important to understand this way of working also. Right. In this way, you will understand the concept. You will get thorough conceptual clarity that you have 5 slots and first slot you have 10 options. Then second slot 9 options, third slot 8 options, etc. Here also it will do the same thing. 10 factorial is 10 into 9 into 8 into 7 into 6 into 5 factorial, right? 5 factorial is 5, 4, 3, 2, 1 by 10 minus 5, which is again 5, 5 factorial. This 5 factorial will get cancelled, and then what will be left is the same thing, 10, 9, 8, 7, 6. Multiplication of, right? So it is important to understand permutations this way, that how many slots are there, and for each slot, what exactly is the option that is available. Very good. Next, let's do another important problem. How many words can be formed by using all the letters of the word daughter so that the vowels always come together? Vowels should come together. What are vowels in this word? A, U, E. There are three vowels, right? So he's saying all three vowels should come together. Whatever may happen, all three vowels should come together. So let's write the letters like this: D, G, H, T, R, and A, U, E. These are three letters, they should always come together. Right. Now, what does that mean? If these three letters should always, anyway, they cannot be split. Right. So, what we do, we'll assume instead of these three letters, there is only one letter, which is X. Right. X can, then when you do permutations, right, we'll try to do permutations with this X. Right. 1, 2, 3, 4, 5, 6 in this case. Right. There are six letters. Now, with the six letters, we'll have six factorial combination permutations, right? 6 factorial is 720. Right. If instead of this A, U, E, there is only one X, how many permutations are there? Then there are 720 permutations. Forget about A, U, E. Let's assume there is only all A, U, E combined together is only one X. If actually there are only six letters, then it is 720 combination. But this X is not actually single one. Right. This X, whenever in all these permutations, this X will sit somewhere. Right. Because it's always six letters. In every permutation, this X will be sitting somewhere. Right. Basically, we are making this 1 to 720 permutations. In each of these 1 to 720 permutations, X will sit somewhere. Right. For example, X will sit between G and H, D and G, D and T, whatever, whatever. There are 720 permutations. All the 720 permutations will have this X, will have this combination AUE. But this X or this AUE, they themselves can be ordered in three factorial ways. Right, because they themselves these are supposed to be together, but not necessarily in the same order, right? It can be AEU, or UAE, or UEA, whatever, right? There can be multiple orders within these three also. These three can sit within themselves in any order, but these three have to be together. So then what we do? So we assume that these three are together, and we assume that these three are one letter only. Then if this is taken as a set, then with this set there are 720 permutations are possible with this set together. Now within this set, when there are 720 permutations are possible in each, for against each set, this AUE can again be ordered in six different ways, right? So, for example, we created this combination only. This combination only. Then that is DGHTR X only. Then that means, what does it mean? AUE, AU, AUU, AUU, UAU, UAA, similarly UA, EAU. Right. So all six combinations are possible, right? The first one can be A, then these two exchange, first can be U, then these two exchange, first can be E, then these two exchange, right? So all the 720 will again have six different permutations, right? So that's why 720 into 6, right? You have understood this, right? So in this kind of problem, what we have to do, we have to assume that all vowels are together. If vowels are together, if instead of three vowels, if there is only one vowel, or instead of these three vowels, let's say there is only one set, how many permutations are possible? That is 720. Now, within this 720, after this 720 are possible, all 720 can be ordered in 6 different ways. So 720 into 6, that is 4320. Right. Next, how many words can be formed from the letters of the word extra so that vowels are never together? This is even more interesting. In the earlier case, in this case, vowels are all together. This time vowels are not together. So E and A can never be together. This is what he is saying. But how do you solve this problem? This is even more interesting. Right. Let's let's assume again this E and A are together. Then how many permutations are possible? One, 2, 3, 4. 1, 2, 3 extra. Let's say what are the total permutations that are possible? One, 2, 3, 4, 5. Five letters are there, right? What are the total permutations that are possible? We have five letters, all different, and we have five slots. So 5 factorial, simple. 5 factorial is 120. This is the total, right? Now, if vowels are together, how many permutations are possible? In the last case, if all the vowels are to be together, that means E and A have to be together. So what means that means how many will be possible? One, two, three E and A together. So total 4 factorial into E and A, they can be ordered in E first or A first into 2 factorial. 2 factorial is actually 2. Right. X, T, R and E and A together. Total 4. Total 4 slots. And within this, we can have again 2. Right. So first we'll order 1, 2, 3, 4. 4. Then 4 in 4 factorial ways. And after that, each of these 4 factorial ways it can be ordered E first or A first into 2. So that is 48. 48 are the places, 48 are the cases, 48 are the permutations where E and A will be together. Now he is saying how many words can be found where they are not together. Remaining all the cases are the places where they are not together, right? So total is 120, 48 are together. What does that mean? 72 are not together. This is the way to have to solve. If we try to go and solve for the cases where it is not together directly, it will become very difficult. Instead, what we should do, we should take the cases where they are together and then subtract them from the total possible cases. Right. Next, another important problem. How many arrangements? So, by the way, these are all questions that have come in the previously in the government exams also. So that's why these are very important. Please try to understand. If any problems, if any doubts, please uh, please message. Then we'll pick them. How many arrangements can be made out of the letters of the word engineering? Right. So here you should understand one thing. Here some letters are actually repeating, right? So so when letters are different, we assume if it is there are 10 letters, all 10 are different, then we said 10 factorial, right? When there are 5 letters, all 5 are different, we said it is 5 factorial. But what if the case some letters are repeating, right? So for example, engineering, E is how many times? E 1 2 3. E 3 times. How many times N is there? N is also 3 times. G how many times? G is actually 2 times, right? Then I is how many times? I is also 2 times. Then R. R is how many times? R is 1 times. R is 1 time, right? We covered all of them. E 3 times, N 3 times, G 2 times, I 2 times, R 1 time. So in this kind of problem, what are the total number of letters? Total number are 11 letters. 11 letters. So please note, if you say directly 11 factorial, then this will be definitely wrong. Because 11 factorial would be for when all the letters are different. When some of the letters are same, then whether you put this E first or this E first or this E first, it doesn't matter, right? So you can always say when there are some letters which are common, then it should be definitely less than 11 factorial, right? It should be somewhat less than 11 factorial, because 11 factorial is the case when all letters are different. But if some letters are same, so whether you put this letter first, this you put first E first or second E first or third E first, it doesn't matter, right? So let's think like this. So for example, if all letters are same, right? E, 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 like this, there are 11 letters. All letters are same. Then how many ways can you order this? Then there is only one way, right? For example, if all letters are same, then you can order them in one way only because you put this E or that E, this E doesn't matter. Even if there are 100 E's, if all letters are same, you can arrange them. There is only one letter that will come ultimately because all letters are E's only. There is no way, right? So this is the extreme case. So as the number of letters increase, then and as the number of repetitions of letters increase, the number of permutations will go down. The extreme case is when all letters are same, then the permutation will become one only. Right. So in this case, the new formula is actually, let's say in this case, what will happen? There are E's, so we have to find out how many different letters are there. 1, 2, 3, 4, 5. There are actually 5 different letters. Then 3, 6, 2, 6 plus 4, 10 and 11. So total 11 letters are there, but in distinct 5 letters are there. In this case, the new formula will become 11 factorial by 3 factorial into 3 factorial into 2 factorial into 2 factorial into 1 factorial. Like this. How many repetitions are there? Those all will come in denominator. In this case, what will happen? If all E's are there, then 11 factorial by the one E is actually getting repeated 11 times. So 11 factorial by 11 factorial, which is equal to 1, which which is also true, right? It should be one permutation only, right? If all the letters are same, then there is no way you can create more than one word, more than one permutation, because whichever you write first, it doesn't matter. You'll still get all these word only, right? So in this case, when the numbers are getting repeated, when the numbers are getting repeated, or when the letters are getting repeated, what we do? So 3 factorial. So how many times they are getting repeated, we have to write that down, and we divide this whatever total 11 factorial by total number, whatever is this. Right, total 11 letters are there, total 11 factorial by whatever all this number of repetitions. Right, so E is repeated twice, so that's why 3 factorial into again N three times, so 3 factorial into Z 2 factorial into I 1 factorial into 2 factorial into R, which is 1 factorial. Right, so this becomes, if you calculate 27 11 factorial by 11 factorial by 3 factorial by 3 factorial into 3 factorial into 2 factorial into 2 factorial. This will become 27 200. If you calculate, right, you can try to it outside. Next, in how many different ways can the letters of the word software be arranged in such a way that the vowels always come together? The same kind of problem. How many letters are there? 1, 2, 3, 4, 5, 6, 7. 7 letters are there. 1, 2, 3, 4, 5, 6, 7. Right. Now vowels have to be together. How many vowels are there? A and E. Let's combine A and E and define that as a single letter. If there was a single letter, then how many permutations will be possible with 1, 2, 3, 4, 5? The sixth big letter, then it will be 6 factorial, right? Now after the 6 factorial is done, A and E can be defined as AE or EA. So which is 2 times, which is equal to 2 factorial. So what are the total permutations? So whatever first, when we take A and E together, that is 6 factorial, and each of this 6 factorial can be defined actually, can be rewritten in two different ways, A first or E first. So 6 factorial into 2 factorial, which is 720 into 6, 4320. This is the same problem. In how many different ways can the letters of the word mathematics be arranged so that vowels always come together? This is little tricky because here vowels are also repeating, A is repeating sometimes, and even consonants are also repeating. Right, M is repeating, T is repeating, etc. Let's rewrite this word. Mathematics. Let's pull out vowels out. Okay. M, T, H, M, T, C, S. When we remove all the vowels, these are the letters. Then let's put vowels here. A, E, A, I. A, E, A, I. Now, how many ways? Let's say all the vowels have to be together. Let's assume all the vowels are replaced with one single letter. So how many letters are there now? 1, 2, 3, 4, 5, 6, 7, 8. Right. So 7 consonants and one big vowel. Right, one replaced vowel. So 8. 8. So with 8, and among this 8, there are how many repetitions? M is repeating twice, T is repeating twice. Right, there are repetitions, right? Total 8 letters are there with one big vowel letter, and there are 2 repetitions in this 8 letters. So what are the total permutations? 8 factorial by 2 factorial, 2 for one M and another 2 factorial for one T, because T and M are repeating. Right, 8 factorial by 2 factorial into 2 factorial. Now after that, these 4 can also be ordered in different ways. How many ways these 4 can be ordered? Right, there are 4. Right. So 4 factorial by 2 factorial, because it's A is repeating twice. So 4 factorial by 2 factorial. So basically, when we are pulling out all vowels outside and assuming that it's all vowels is a single letter, then total permutations are 8 factorial by 2 factorial into 2 factorial. Now after that, even these vowels can also be ordered in 4 factorial by 2 factorial ways. So what are the total number of ways? This into this, which becomes 120960. Right, another interesting problem. In how many different ways can the letters of the word machine be arranged so that vowels may occupy only the odd positions? Machine, how many letters are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And how many odd positions are there? 1, 3, 5, 7. Right. So now we have 3 vowels and 4 odd positions. How many ways these 3 vowels can be? In fact, this is equal to picking 3 slots from available 4 slots. Right. And ordering. Basically, uh, picking and ordering, right? So how many permutations are possible from 4 available, and we have to pick 3. So 4p3, which is actually equal to 24, right? Once you pick 3, how many are still left? 4. Right, total 7, 4 are left. And how many consonants are left? This time again 4, but these 4 consonants are all different. So 4 consonants, 4 different. How many ways they can be arranged? That is again 4 factorial. So 4 factorial ways consonants can be arranged, and another 24 ways this A, I, E can be arranged in the 4 slots. So total how much? 24 into 24. Right, 24 square. Right. So don't get confused. First, we have to separate A, I, E. And A, I, E, and we have 4 slots. For these 4 slots, we can arrange this A, I, E in these 4 slots in 24 different ways. Once this is arranged, once this is arranged, 4 slots, we cannot arrange in all the 4 ones, right? We can only, at any point, we can only pick 3, because there are only 3 letters. Right. After this thing is done, 24 ways of putting these 3 vowels in 135 or 357, 157, whatever. Then again, the remaining 4 slots we can fill with consonants in 4 factorial number of ways. Right. So 24 into 24, 576 is the correct answer. Right. Hope you understood this. Any questions, please comment. We will continue this exercise. Thank you guys. All the best.